All right, to begin, we're going to deal with perfect squares. So this is taking something like x minus 3 and squaring it. What happens here is this does not mean x squared minus 9. All right, we cannot distribute this 2 over subtraction. We've already talked about that many, many times. We cannot distribute that 2. What this means is actually take whatever's in parentheses and multiply it by itself. So x minus 3 times x minus 3. And I'm going to use FOIL. So I wind up with x squared minus 3x minus 3x again. So here's my outers and here's my inners, and then plus 9. And the end result is x squared minus 6x plus 9. All right, now let's do this with a and b, and we'll talk about how it relates to that. That, by the way, is called a perfect square trinomial. Let me write that. I'm going to not use magic marker because it's not going to fit. A perfect square trinomial. That's a very special thing. We'll talk about why as we go forward, but it is a trinomial. It's made of 3 terms, and it is a perfect square because it's the square when something, it's the result when something got squared. This thing got squared, therefore this is a perfect square trinomial. Okay, this binomial got squared. All right, so let's take a look at a plus b squared and a minus b squared. So that means we're going to take a plus b times a plus b. Okay, so a times a is a squared. A times b is ab, and a times b is another ab. So we wind up with 2 ab's. I'm going to combine like terms. I'm basically taking these 2 pieces and combining them in one shot because I don't have enough room here. But a times b is ab, and a times b is another ab. So therefore we have plus 2ab. And then b times b is plus b squared. All right. If we use subtraction, a minus b squared, a minus b times a minus b equals a squared. Now, minus ab and minus ab, my outers are a times negative b, and my inners are a times negative b. So they're both negative ab. So we wind up with 2 of those, 2 negative ab. And then negative b times negative b, that's positive b again, or positive b squared rather. Now notice the only difference here is this negative sign. Okay, so we multiply a binomial by itself. We wind up with the first term squared. Let's see if I can circle these this way. The first term winds up squared. All right, notice here the first term winds up squared. Okay, we wind up with the last term squared. The last term squared. Okay, and then we wind up with this middle term. This middle term. This is the key thing. This middle term. This middle term. This middle term is the first term times the second term times 2. So a times negative b is negative ab times 2. A times b is positive ab times 2. Negative 3 times x is negative 6x. Or sorry, is negative 3x. Negative 3 times x is negative 3x times 2 is negative 6x. That always happens. So in thinking about this way, we can square the first term. So here I have another example down here. We're going to square the first term, square 2x. So that's 4x squared. We can square the last term using the same colors here, the orange. We can square the last term and get plus 25. And we can square, well, not square, we can multiply the first term times the second term and then multiply that times 2. So negative 5 times 2x is negative 10x. Negative 10x times 2. And that becomes minus 20x. And this also is a perfect square trinomial. All right, on this one, if you have questions, let me know, okay? This is a nice pattern to recognize because it's going to help you when we go to factor perfect square trinomials, which will happen commonly. And basically, you should be going, oh, look, that's a perfect square, and that's a perfect square. Ooh, wait a second. If I take, is this how somehow come from a perfect square binomial that's been squared? So that's what this pattern is really about. But it's also about being able to square something quickly.